So we have been working with finding enthalpy changes in reactions. We've done calculations with Hess's law. We've done finding delta H with heats of formation. We've found heat of a reaction using Q equals MC delta T. Yet another way to find the enthalpy change of a reaction is to use bond energies. There are tables of bond energies that tell us how much energy is stored in a bond, so therefore how much energy it takes to break the bond and how much energy is released when that bond is formed. These tables are averages. They're not exactly what the energy will be for a particular bond in a particular molecule, because the energies can vary according to the environment that this molecule or this bond is in. But in general, we can make some generalizations about the energies of each bond according to the number of electrons they are sharing. So if you remember, a single bond shares 1 electron, double bond shares 2 electrons, triple bonds share 3 electrons. The more electrons that are shared, the greater the bond length. So if we kind of summarize that, let's see here. There we go. Maybe. So a single bond has the least or the smallest bond energy, where triple bonds have the most bond energy. But then if we look at bond length, single bonds have the shortest length. Actually, I just lied. The longest length, where triple has the shortest. Which kind of makes sense. The more electrons that are being shared, the tighter the two atoms will be to each other, and the more energy it will take to break that bond. So, in summary, in order to break bonds, energy must be added to the system. That part would be endothermic. We would say delta H is positive there. To form bonds, energy is released, and that's exothermic. So in order to, if we just think about this kind of conceptually, I'm going to put energy in to break bonds. Energy is going to come out when bonds are formed. If it takes more energy to break than is released, it's going to be an endothermic reaction, and vice versa. So here's the overall formula. The sum of the moles of the bonds broken minus the sum of the moles of the bonds formed. And D just represents bond energy per mole. That's why we have to multiply it by moles, so that moles will cancel, and we'll just get energy for our delta H, or our enthalpy. So here's a practice problem. What is the enthalpy change for the following reaction? They give us a bunch of bond energies. The carbon-hydrogen single bond would have a bond energy of 413. Carbon-nitrogen single bond has a 305, and so on. So in order to do this reaction, we have to look at what bonds need to be broken and what bonds need to be formed. So on this side, I am going to write my bonds I'm breaking. And if I look at this substance, you can see these would be carbon-hydrogen single bonds, single bonded to the nitrogen, then triple bonded to the carbon. Over here we have carbon single bonded to 3 hydrogens, single bonded to another carbon, triple bond to a nitrogen. So here I am breaking CH bonds, 3 of them. I am breaking a carbon single bonded to nitrogen, just 1 of those, and then I'm breaking a carbon-nitrogen triple bond, also just 1 of those. On the make side, I am making 3 carbon-hydrogen bonds. Just going to erase this a second. Three carbon-hydrogen bonds. I'm making one carbon-carbon bond, and I'm making one carbon-nitrogen triple bond. So to do my math, like we said before, we have to put energy in to make, and to put energy in to break, and energy in to make. So when we do the math here, I have 3 moles of the carbon-hydrogen at 413 plus 1 carbon-nitrogen at the 305. This is all energy going in, plus the triple bond, which was 891. All of that is energy in minus energy coming out. So that's going to be 3 times the 413 coming out, plus the 347 for the carbon-carbon single bond, and there's one of those, plus the 891 for the carbon-nitrogen triple bond. Energy coming out. When you put all of this on your calculator, you end up getting negative 42 kilojoules. Your moles all cancel when you multiply it by the coefficient. And this tells me that this is an exothermic reaction. This is, I think, the 4th way we have talked about determining enthalpy of a reaction.